Hi, it's 1T. In this video, I will be going over set operations and Venn diagrams with three sets. So really, we're doing the same thing we were doing before with two sets, just another set. So you may want to try numbers 1 through 4 and then watch the video, or just watch the video. All right, so let's go ahead and get started. So notice on the first problem, I need to know a complement, and I don't know what a complement is, so I'm going to find a complement. It's everything that's in the universal set that's not in this set. So notice we have in the universal set the odd numbers from 1 to 15. So we have 1, 3, 5, 7, 9. So it's just going to be the odd numbers greater than 9. So that would be 11, 13, and 15. And so I'm going to go ahead and write that set right here. 11, 13, and 15. And we're going to intersect that with B union C. So basically we need to combine these two sets together. So I'm going to go ahead and just do this in one step. Let's start with the 3 and then 5, and then we'll have 7 and 9. So 3, 5, 7, 9. So we have those 4, and then we have 11, 13, and 15. So when I think of union, I think of the word combine. And if you combine these sets together, you get this set here. Notice 7, 9, 11, and 13 are in here. 3, 5, 11, and 15 are in there. And so now we just need to find the intersection. It's going to be 11, 13, and 15. And that'll be our final answer. All right, let's move on to the next one. Again, at any point you might want to stop the video and try it on your own when you think you've got it, and then you can check your answers. So here we have A, which is 1, 3, 5, 7, and 9. And we're going to union that with B intersects C. So B intersects C, that's what these two sets have in common, or the elements they have in common. Well, 7, 9, those are not in both. 11 is, and it looks like that's it. So if we union these together, basically combine them together, we're going to have 1, 3, 5, 7, 9, and also we'll add 11 to that. So it's 1, 3, 5, 7, 9, and 11. All right, let's move on down. A union B. So if we combine the elements in these two sets, notice this has 1, 3, 5, 7, 9. 7, 9 are repeated here. We're going to need to add 11 and 13. So it's going to be 1, 3, 5, 7, 9, 11, 13. 1, 3, 5, 7, 9, 11, 13. And then A union C, we'll combine these together. We're going to have 1 and 3, 5, 7, 9, 11, and 15. So it looks like we're only missing 13 from all the elements in the universal set. So this will be intersect 1, 3, 5, 7, 9, let's see, 7, 9, 11, 15. So it looks like we have everything up through 11. So 1, 3, 5, 7, 9, 11. That looks like that's what we have in common, or those are the elements in both sets. Whoops, 5, 7, 9, 11. And that's going to be our final answer. All right, so here, A union B, we just found. And so it's 1, 3, 5, 7, 9, 11, 13. Well, in the universal set, the only number we don't have is 15. So this is just 15. And we're going to intersect that with C. 3, 5, 11, 15. And of course 15 is the only element in both of those sets, and so that's going to be our final answer. Alright, let's move on to the next part here. Venn diagrams with 3 sets. Alright, so these are the regions, 1, 2, 3, and so on. There's a total of 8 regions. Notice we're using Roman numerals. So which regions represent set B? Well, it's basically everything in the B circle. So we've got 2, 3, 5, and 6. 2, 3, 5, and 6. Whoops, I just need a 5 there. Okay, A intersect B, that's the elements that A and B have in common. That would be this overlap here. So that's just 2 and 5. Which regions represent A union C? So if we combine everything in A with everything in C, it's basically everything except for those regions there. So 1, 2, 4, 5. 1, 2, 4, 5. And then we also will have 6 and 7. So again, it's everything but these regions. 6 and 7 also need to be included. Okay. Let me go ahead and move this up a little bit. Okay, A naught, or the complement of A, is all the elements that are not in circle A. So basically, these regions here, so 3, 6, 7, and 8. 3, 6, 7, and 8. A intersect B intersect C, that's basically what the 3 circles have in common. That's only going to be region 5. Which regions represent A intersect B and not C? Alright, well first A intersect B, that's this part here. Not C would be everything outside of C, so you could basically do something like this here. And you can see the intersection, because we're looking at an intersection here, with not C is this part here. So that's just going to be 2. The overlap is this set, or this region. That's the only place that these 2 sets have in common. So not C, that's all of the stuff outside of C. And this was the other region we had. What's in both sets, or in both regions? That would be 2. Now there's another way you can logically think of this. It's A intersect B, which is this region here, and not C. We'll cut out C, and what you have is just 2 there. So it's this part here, but not C. And so that'll just be region 2. So I'd encourage you to try to do something similar with number 11. and then watch the video. I'm going to go ahead and erase these marks because I need some new marks, I think. Alright, so let's do this last one here. B union C, you're going to combine everything in B with everything in C. So that's everything except for region 1 and 8. Everything that's in those two circles. But we're going to intersect that with not A. So we're going to take all of this, but we're going to exclude A because it's not A. So what's left? That would be 3, 6, and 7. 3, 6, and 7. Alright, so it's everything that's in B union C, that's these two circles here, but not A. So it'll be those three regions. Okay, I think that's the easiest way to do a problem like that. The other thing you can do is actually find this region, and shade each of them differently and see what they have in common. You get the same three regions. Alright, let's move on. So on number 12 here it says use the Venn diagram to find each of the following. First of all, A. Now again, if you feel like you can do this, you might want to go ahead and do it and then watch the video and check yourself. Now everything in A, that's all the numbers in circle A. So what's that? 3, 5, 6, 7, 11, 12? 3, 5, 6, 7, 11, and 12. All right, A union B, that's everything. We're going to combine everything in A and the B circle. So that's these two circles here. So it's really everything but 4 and 8. We've got 1, 2, 3, 5, 6, 7. 1, 2, 3, 5, 6, 7. After 7, there's no 8. We have 9, 10, 11, 12. 9, 10, 11, and 12. Let me just double check that I see that I didn't miss anything. That looks good. B intersects C. Let's see, that's what B and C have in common, so that's basically this region here. So 5, 7, and 9. Not C, or the complement of C, is everything in the whole, this is the universal set, everything in the universal set that's not in C. So we've got 1, 2, 3, 4, 11, or 10, 11, 12. 1, 2, 3, 4. Let's see, not C. 10, 11, 12. All right, A intersect B intersect C. That's what the three circles have in common. So 5 and 7, the elements in here are the only ones that are in all three circles. So this will be the set with 5 and 7 in it. Let's see, on F, we got A union C. So this will be kind of like the last two that we did on the previous page. A union C is everything in the A circle combined with everything in the C circle. However, this is and not B. So we have to take out the stuff that's in B. So it's going to be 3, 6, 8, and 11. 3, 6, 8, and 11. Now that's the way I like to do it. The long way would be to find A union C. And I'll just tell you it's 3, 5, 6, 7, 8, 9, 11, 12. And intersect that with B complement. That's everything that's not in B. That would be 3, 4, 6, 8. And 11. I almost missed 11. 3, 4, 6, 8, and 11. And if you see what these two sets have in common, it's 3, 6, 8, and 11. All right, so you can do that either of those two ways. Let's move on to number 13. It says a math tutor working with a small study group has classified students in the group by whether or not they scored 95% or above on each of 3 tests. Use the Venn diagram to represent the following. The set of students who, and by the way, I would highly encourage you to try this on your own and then watch the video, and hopefully if you miss anything, the explanation will clarify. So let's see. The set of students who scored 95% or above on exam 3, so they're in this circle, and not on exam 1. So they can't be in here. So they're in this circle because they scored better than 95% on exam 3, but not on 1. So that would be Pat, Don, and Nye. Pat, Don, and Nye. All right, the set of students who scored 95% above on exam 1, that's here, and exam 3. Now, it's an and statement, so this works like intersection. So what is in these two circles? So they scored 95% on exam 1 and also 3. That would be Jen and Bill. That's this overlap here. They're the only ones that are in both circles. So Jen and Bill. All right, next we have the students who did not score 95% on exam 1, 2, or 3. So they're not in any of these circles. That would be these guys out here. That's Mel, Lori, Gus, and Ava. The set of students who scored 95% or above on exam 2, so they're in here, and not exam 3. So they're in here, but they're not in 3. That means it would be TJ and these 3 here. So TJ, Ellen, Mart, and Ollie. All right, on E, the set of students who scored 95% or above on all 3 exams. Well, that would be this region here. This is the only place, anybody in here scored 95% or better on each of the 3, so that's just going to be Bill. The set of students who scored 95% or above on only 2 exams. So here, these are the ones that scored 95% or above on exam 1 and 2. Here on 1 and 3, it looks like it's just going to be TJ and Jen. Those are the only ones that scored 95% or above on 2 of the exams. These are the regions we're going to be checking. Oops, and I'm sorry, I went off the grid there. So TJ and Jen are the only ones for letter F. All right, I'm going to go ahead and stop the video here and do a second one.